Surface texture and its evaluation. The contents include the definition and types of surface textures and its nomenclature and evaluation. A surface texture is the nature of a surface, and it is also known as surface finish or surface topography. And this is mainly because of the manufacturing process we are using, and each manufacturing process produces different surface textures, and it comprises small local deviations of a surface from perfectly flat ideal surface. Because ideal surfaces are difficult to produce, so some deviations are always present with the surfaces, and these are actually comprises the surface texture. The various properties of the surfaces or the parts are influenced by the surface texture. Some are listed below. One is appearance. So it will have a finished appearance or a rough appearance with respect to the texture. Then corrosion resistance is increased with the finished surface and it decreases with the rough surfaces. Wear resistance also increases with the finished surfaces and it decreases with the rough surfaces. And the fatigue resistance, again, finished surface has got more fatigue resistance compared to rough surfaces. In lubrication, some surfaces are finished to have better lubrication, especially in ball bearings like that, in order to reduce the friction. But in some other cases, especially in bore of IC engine cylinders, we will give some particular surface texture to retain the lubricating oil on the surface. Then initial tolerance is also affected by the surface texture, then load carrying capacity, and also noise reduction in case of gears. For a rough surface, the noise will be more, and for finished surface, the noise will be less. The surface texture or nature of the surface can be defined using uh, roughness of the surface, waviness, and lay. And discussing all these terms is coming under the terminology of surface texture. From the available surface regularities, if we could filter out the closely spaced irregularities like this, then it is known as the roughness. And the average height of this roughness is known as roughness height, and the average spacing is known as the roughness spacing. Then the next is the widely spaced irregularities, that is known as waviness, and its spacing is known as waviness spacing, and its height is known as the waviness height. If we combine these two, the roughness and waviness, then it will appear like this in this picture, and this is known as the profile of the surface. The direction of the predominant pattern produced on the surface is known as lay, and the scratches or some other irregularities which is appearing on this surface is known as flaw. The cutting tool marks or a grit of grinding wheel, etc., are responsible for these roughness patterns, while the vibration and chatter of the machine is responsible for the waviness. There are different types of lay patterns, depends on the direction. If it is parallel to the reference edge, like in this picture, then it is the parallel one using this symbol. If it is perpendicular, then the symbol will be this one, and angular is represented like this. Multidirectional means there is no definite direction, all directions lay is present. And circular means it is approximately circular with respect to the center of the workpiece, and the radial is shown like this with respect to the center of the work. In measuring the surface roughness, we take a small length of profile necessary for evaluation, and that is known as sampling length. It is also known as cutoff length, and this table shows the different cutoff length or sampling length required for different uh, processes. After measuring the surface finish, its evaluation is made using any of these methods. One is peak to value height method. Second one is the average roughness. And third is the form factor of bearing curve. Then the average roughness is further classified as CLA method, or otherwise centerline average method. It is denoted with RA. Otherwise, we are using root mean square method or RMS method denoted with RQ. 10-point height method is also used. It is denoted with RZ. Then total height method is used. Then that is denoted with RT. The evaluation of surface roughness is based on the roughness charts. And the roughness charts are made by enlarging or magnifying the output obtained from the measurements. And if this is a true shape, it will be made to distorted shapes for the measurement. The distorted shape is made by using two scales of magnification. We will use a large scale for vertical magnification and a very small scale for horizontal magnification. So the ratio of vertical to horizontal magnification will be around 100:1. Then we will get a distorted shape of roughness chart, and this chart is used for evaluation of the roughness. In peak to valley height method, we construct two parallel lines L1 and L2, and the condition for this construction is like this. For L1, it is actually passing through all the peaks, and the distance of the peak, the width of the peak above L1 is measured as P1, P2, P3, etc. And the sigma P, that is the total of all the P, should be equal to 0.5 of the total sampling length. And similarly, L2 should be placed such that the width of all the valleys measured as V1, V2, V3, V4, etc. And the sum of these valleys widths should be equal to 0.1 of the sampling length. Then we will measure the height between L1 and L2, and that is the measure of peak to valley height. In most of the average roughness methods, we need to construct a center line through the profile. In this roughness chart, this one is the mean line. The mean line is constructed such that the area of the profile above mean line should be equal to area of the profile below mean line. So we have to measure all the areas above the mean line and below the mean line, and it should be equal. If it is not equal, we have to shift the mean line either in upward direction or in downward direction to get this condition satisfied. The first method in average roughness is centerline average, that is CLA method. And in CLA method, throughout the sampling length, we are dividing it into equal number of parts, and for each number of divisions, we will calculate or measure the height of from the mean center line to the profile, and it is recorded as H1, H2, H3 up to Hn, and the CLA value is given by sigma of H by N, or otherwise H1, H2 up to Hn divided by N. The roughness value can also be calculated in CLA using this equation. Instead of dividing into different parts and finding the heights, we can measure the area using a planimeter, that is area 1, area 2, area 3, etc. And the CLA value can be calculated as sigma of this A divided by L. The L stands for the sampling length. In root mean square method, the procedure is same. We are dividing it into number of divisions and calculating measuring the heights from mean line to the profile. But the equation used is modified like this, and it is now root of sigma h square divided by N. In 10-point height method, instead of constructing the center line, we construct a baseline or a data line from a distance, and the distance from the data line to the profile for all the peaks and all the valleys are constructed and it is measured. Then we will choose highest peaks as R1, R2, R3, R4 and R5, and the distance is recorded like this. And also we choose the lowest valleys, that is the smallest distances, that is recorded as R6, R7 and up to R10. Then using this equation we will find the 10-point height method of irregularities, or the RZ value of the roughness. In total height of profile method, again we are constructing the center line, and throughout the sampling length we will find the tallest peak and the deepest valley, and its readings are recorded, and the total height is the sum of the tallest peak and the deepest valley, and that is given as RT. In form factor method, the material above the arbitrarily chosen baseline in the section is calculated. So this one is the baseline that is arbitrarily chosen, and the material is marked, and the form factor is calculated using this equation, that is the area of the metal divided by the area of enveloping a rectangle. This one is the rectangle. So that is the form factor. So by knowing the form factor of a profile, we can compare it with another profile. In bearing area curve method, the profile is redrawn like this with respect to the bearing area, and for that we are constructing a number of parallel lines in the profile which is passing through the profile, and in each lines we will recalculate or re-represent the bearing areas like this. This length L is equal to this length L1 plus L2. So similarly here also it is A, B, C, and it is added upon, and this distance is obtained. So by this we will reconstruct this profile like this, and the area is calculated, and this is known as the bearing area curve, and the bearing area curve of different profiles can be compared to check the roughness of that surfaces. And this method is commonly used in the engineering and manufacturing of piston cylinder boards of internal combustion engines. Thank you for watching.